Okay, so we can do this one also. So this is between here and here, and I'll just scroll through the answer. You can stop the video and check it. So we want, they figure out this area here, and I'll just scroll through. Finally, we get the answer like that. Okay, so let's keep going here. Oh, if you want to stop and look at those, you can. So next topic is standardizing a normal distribution. So if you have a normal distribution, but it's not the standard normal distribution. So remember way back here, way back. So these are all normal distributions, but they're not the standard normal distribution. These are also normal distributions, but they're not the standard, because the standard normal distribution, we said, has to be centered at 0. This is centered at 20, this is centered at 30, this is centered at 40, and they also have to have spread of 1. These all have spread of 2. So these are not. But for a normal random variable that's not already standard normal random variable, a particular value of x can be converted to its corresponding z value by using this formula. So this looks confusing, but let's try it out and see what it means. Just try to remember it's x minus mu over sigma. Let's see how we use that. So let x be a continuous random variable that has a normal distribution. So it is normal, but it's not centered at 0. It doesn't have a mean of 0. It has a mean of 50. And it has a standard deviation not of 1, but of 10. Convert the following x values, this one and this one, to z values, and then find the probability to the left of these points. So let's see if they do it like this. So what they've done is, here's the mean for this random variable was 50 and a standard deviation of 10. So let's look at that. So the mean, the center is 50 and a standard deviation of 10. So what they want you to do is, they want you to convert 55 to a z value. What that means is, all they really want you to say is, how far is 55 from 50? Well, obviously, 55 is 5 from 50. But they want to know how many standard deviations is it from 50. So that's all they really want you to do. So how many standard deviations is 55 from 50? It's 5 units, but a standard deviation is 10 units. So it's not even a full standard deviation. It's half of a standard deviation. So we say that the z value for this 55 is half, or 0.5. Because how many standard deviations is 55 from 50? Well, it's 5 units from 50, but the standard deviation is 10, so it's only half of 10. So it's only half of a standard deviation. So that's all they want you to do, to convert 55 to how many standard deviations it is. So how did you do that calculation? How did we get from 55, how did we get a half? So what we did is we took 55 minus 50, which is 5, and then we divided it by the size of the standard deviation. So 5 over 10 gives us that half. So what did we do? We took 55 minus 50 over 10. So this formula gives it to us. So that's what they do here. Take 55 minus 50, 55 minus 50. So the value that you want to convert, so we want to convert 55, minus the mean, minus 50. How far is 55 from 50? And then divide by the size of the standard deviation, divide by 10. we get this. Okay, so then the other part of the question was, find the probability to the left. So what they're saying is, since this is normally distributed, I want to know the probability to the left of here. It's going to be the same, or I'm sorry, I want to know the area to the left of here, this area. That's going to be the same as the area to the left of 0.5 in the standard normal curve. So what we do is we convert this to where it would be on the standard normal curve, and then we can look it up in the standard normal curve table. And so we can say, oh, this area is something, and that means this area is the same. That's how we do it. So the probability that x is less than 55, that x is less than 55, this is x, is equal to the probability that z is less than 0.5. But we can look up z is less than 0.5 in the table. This is part B. Where's part A? Here's part A. The probability that x is less than 55 is equal to the probability that z is less than 50. And we can look that up in the table, and I'll let you look that up, and it turns out to be 0.6915. So the answer to the question is, convert it to the z value. Well, we did that, it's 0.5. And then find the probability to the left, and that is the probability we just got. And then do the same thing with 35. So I'll let you look at the answer for 35 here, and look it up in the table, and get 0.0668. And that shows that to the left of 35 is this area. So you have the x value here, and underneath we can put the z value, the corresponding z value. So 35 is 1.5 standard deviations below 0. Okay, here's some more. I'll let you look at these. Here's some more. Another one. Here. Okay, I'll let you do these yourself. Another one. Okay, and then we talk about when can we use all of this about normal distribution. So we'll stop the video and come back to that.